Hello again, everyone. This is Stractify 500, and we are back with the Cone of Vision Part 1b. Okay. In Part 1a, in this particular drawing, you can go back and watch it. I use this rough drawing to explain the concept of the Cone of Vision, and I'll just go over it real quick. So basically, when we talk about the cone of vision, we're not talking about an ice cream cone like this, okay? This is what the cone of vision actually looks like, okay? So this might look a little bit weird with this circle and then these lines cutting through. This is our cone of vision that we're using to draw in 1-point perspective. And basically what this represents is we have a person, this could be you, standing here normally and looking directly at an object. And so how this relates to this is that this station point right here is where this person is located, and he is looking to, say, this horizon line, and any objects between here, between the horizon line and I guess himself, is what he sees within this space. And basically, the concept of this that we need to understand is this, everything within this space is, every box, every object is in a normal configuration, a normal point of view. It looks normal, okay? It should look normal. Anything that ventures, any object that ventures outside of this cone will be distorted. What that means in relation to 2-point and 3-point perspective, when you do have 2-point perspective, you have, say, one vanishing point here and another vanishing point here. Everything that is drawn within the boundaries of those two vanishing points is normal, okay? It looks normal, it's what you'd expect to happen. But once those boxes and once those objects venture outside the borders of those two vanishing points, they instantly become distorted, okay? And it starts to show in the drawing. It's easily recognizable, and just those barriers, just the vanishing points, just knowing that an object is outside of those vanishing points, you instantly know that the object is distorted. You won't even need to refer to the vanishing points. You'll see the objects getting distorted. Okay. Same thing with 3-point perspective. Once things get outside the borders of those two vanishing points, they instantly start to look and be distorted. They look weird. They look wonky. They look skewed in a lot of ways. In 1-point perspective, I mean, you have 1 point, okay? With 2-point and 3-point, you have 2 points where, okay, we keep everything within those points and keep everything normal looking. You have 1 point, so at what point, at what juncture do you know that your object is distorted? Is it because it's on this side? Is it because it's on this side? No, because, with 1 point, your objects can be pretty much anywhere. Is it when it's too far, too far away from the point? Is it getting to, like, when do you know it's distorted? And this is a way of measuring that, okay? Because with 1 point, it's not as easy to spot when your objects are experiencing some sort of distortion. With the cone of vision, even if your cubes or your boxes or your objects that you draw, even if they don't immediately look as if they're distorted, once they go outside of this space, this tells you that, hey, your objects are distorted, okay? So what we're gonna do is we are going to go ahead and do some boxes draw some boxes in the cone of vision, and we're going to see how that plays out. Before I get into that, again, go back to cone of vision 1A and you'll see how it's constructed. Let's just remember that you have your single vanishing point, and once you have your vanishing point, you strike an axis, or you strike a vertical perpendicular line all the way down, and then determine where your station point is. Wherever your station point is, you strike a line up to the horizon line, and that line has to be 30 degrees to that axis, okay, on either side. So on the right side, 30 degrees, strike that line to the horizon line. Where it intersects, it gives you that vanishing point. The same thing on the left-hand side. It has to be 30 degrees. Project the line to the horizon line. Where it intersects, it gives you your vanishing point. I'm sorry, not your vanishing point. It just gives you an intersection. This is your vanishing point. One vanishing point, and then you get these two intersections. From the vanishing point to the intersection will be your radius. You take a compass, draw a circle, and that circle in combination with these two radiating lines will be your cone of vision. Okay? So you should have a total of 60 degrees here. All right? Okay, so according to the last video, I had you take my instructions and go and draw your own cone of vision. This is what it should look like. Okay, it's not that different. So let's go ahead and do some quick drawing. I'll start with a blue pen. Let me put these away so that they're not rolling all over the place. I'll put that there. So, and basically I'm just going to sort of eyeball a little bit and keep this kind of quick. So I'm going to have a square here. So all the blue squares within the cone of vision, or I'll place all the blue squares within the cone of vision so that we know what's supposed to be normal and what's supposed to be distorted. Okay, so we'll do that. We'll do something like that. We'll have one right on the, let's put it over here. Straddling the horizon line. So we'll have those three, and let me get the orange and put, and let's see if we notice any kind of change, any kind of weird changes. So I'm going to put one here. Down here. Let's put it down here. Okay. So my boxes aren't perfect. We're just going to get, I'm just doing this to get the general idea in place. And when it's all said and done, you can go and try it out for yourself and basically see how it works. So for this one, I'm not going to bother too much with the inner construction. I'm just going to go ahead and complete it. place your boxes at angles like that. Just make sure everything is parallel and perpendicular. To each other. Parallel, perpendicular line, this is parallel to that and to that, and then, you know, if there are any other aspects, you can't see the other aspects here. Hold on, let me see. I can see a little, just a sliver right there, which means make it dark. It's just a sliver, so you get the idea. All right, so those are those boxes within the cone of vision, and they look kind of normal, kind of basic. Let's see what it looks like with the the ones that are outside. Now, if you want your cone of vision to occupy a lot more space, if you want your circle, the circle for your cone of vision to be bigger, for you to achieve that, you have to drop your station point further down. Okay, so sometimes, depending on what you're going for, you might want to turn your paper lengthwise, orient your paper with the portrait orientation instead of the landscape orientation, or work on a bigger sheet, a completely bigger sheet of paper altogether. Then you can expand all your construction and put more stuff in there. All right. All right, so right off the bat, what am I trying to say? Okay, even though this one is venturing outside of the boundaries, it doesn't look that much different at all. Whereas in something like 2-point perspective or 3-point perspective, even as the object starts to approach the boundary, the boundaries of the vanishing points, you can already start to see the distortion taking place, but not so much here. And let's see this one that's completely out. Let's see what happens. And let me know in the comments section if it's kind of like obvious to you that distortion is taking place. To me, it never is with this technique. Okay, so there's our box. Okay, I'll just darken it, and we'll just take a quick look at it, and I'll talk about a few other things to keep in mind. All right. All right, it doesn't look that much different. This does not look that much different from that, and that from that or that. They don't look that much different from each other. I imagine as you get further out, it probably still won't look that much different. It might look a little more stretched out. But according to the theory and the principle, this part of the box normal, this part of the box distorted. This box is supposedly distorted. Okay, that's how it works. It's not skewing, it's not wonky in any kind of way. So that's just basically how this plays out. All right, so a few things to keep in mind when doing this construction. You are not limited, whenever you're doing some composition, you are not just limited to keeping everything within this circle or within this cone of vision. Your picture plane, you decide what your picture plane is going to be. So you might decide that this is going to be your picture plane, like so. Or this might be your picture plane. You might decide that's going to be your picture plane. Or you might decide this is your picture plane. You are the artist, you are the designer. Play around with this technique and look at the different things that you can get, and you will once you get comfortable with it, you will have no problem determining what you want, what you decide, or what you intend to be your picture plane. And this, depending on how this is positioned, will let you know what objects are being distorted, or what objects are normal. Okay. For instance, you might maybe decide, okay, I want all my 1-point perspective objects to be the focus of my image, and I want those objects to look normal, right? So you might decide that, okay, my picture plane will be way out here and come here, and then even though this will be the focus and it's off to the side, I want this to look normal, and this cone of vision will help you to determine that. Will help you to identify what objects are, supposedly distorted and supposedly normal. Okay, so that's addressing the picture plane and how you decide to use it. Secondly, because you can use all the perspective techniques together, you can have this in place, and then you can decide, okay, this is my cone of vision for all my 1-point perspective objects. I'm also going to have my 2 vanishing points for my 2-point perspective objects within that cone of vision. Okay? So here we're combining the cone of vision, multiple perspectives, and then multiple vanishing points all in one to come up with an interesting composition. So I'll just make this VP1 and VP1, and within this I'm just gonna sort of do a freehand version of this. Compose your 2-point perspective boxes in there as you decide to compose them, or as you decide to illustrate them, depending on what you're going for. That'll be the bottom. Again, I'm just eyeballing, guys, so don't give me a whole bunch of grief. This will go here. Like so. And it should connect there, so get something like that. Right. So you can decide that, hey, all my 2-point perspective objects, or some of my 2-point perspective objects, will be governed by these 2 vanishing points within the cone of vision, And then if you want to get a little adventurous, you can take these points or add other points. So this will be VP, let's call this VP2 and VP2, and then have 2-point perspective objects that are based on these 2 points, which can now exist outside of the cone of vision, say here, but yet still be within the boundaries of the 2 vanishing points. So already you can see that you have a lot of flexibility, and you can do quite a bit with this, but just knowing how the rule works, you will be able to go back and forth and you know, go a little bit wild and throw things everywhere. So you can have some 1-point perspective boxes within this, and let's say we're working with this, and say our picture plane expands even further than that with these 2 vanishing points, these 2 vanishing points, and then this vanishing point. You can have different objects all over the place. Well, of course you want to plan it and have a focal point and a hierarchy and all that kind of stuff. But then you can also have, say, your 1-point perspective boxes exist in here, and then have some exist out here, and then because it doesn't change that much, you can still have it look normal or look the way it looks, and you can still have all these things working together. And then of course you can also have your 3-point perspective working in conjunction with this. So in that case you'd have to determine where your 3rd vanishing point is going to be, and you can set that up to work within the cone of vision or even outside the boundaries of the cone of vision. So there is a lot that you can do with that. And so what you'd have to do is take what I've laid out and go and try it out for yourself. Experiment, go wild, see what you come up with, and have fun with it. It's fun to play with these things. Okay, so there you have it, Cone of Vision, Part 1B. Yeah, there's a lot you can do with that. So this is Stractify 500. Thanks for showing up. I hope you got a lot out of this. Leave your comments and questions down there somewhere, down there in the comment section, and let people know about this channel and about this series, and subscribe, hit the like button, and give me some feedback. Thanks for showing up. I will see you in the next video.